Okay, so this is what we're going to do. We are going to convert our complex numbers into polar form. And the polar form looks really, really weird. And these are the complex, and we can also call them rectangular. Okay, so hold on. Okay, so let me set up a picture for you, okay? So let's think about when we had to graph complex numbers. So remember, complex numbers are in the form a plus bi, where a is our real number and b is our imaginary number. Okay, so if I were to graph a plus bi, I would go to the right a spaces, and then I would go up b spaces, and then I would have this vector, okay? So I moved over to the right a, and then I moved up b, and let's just call this vector r. Okay, so let's say that right here is where our theta is. So this is where we're going to stand. Look, there you are. Looks so nice. Okay, so you're standing there. If we're talking about the relationship between theta, A, B, and R, I can write that cosine of theta equals, so remember our trig function is SOHCAHTOA. So cosine is from this theta is the adjacent over your hypotenuse. And let's just say that I did sine of theta, and sine is your opposite over your hypotenuse. Okay, hold on. Okay, so let's say I wanted to solve each of these for a and b. So in order to solve these for a and b, I'd have to multiply each side by r, and that would get rid of that, and then I'd have r times sine of theta is equal to b, and then I would do the same thing over here and multiply by r on each side, and then I would have r times cosine of theta is a. Okay, so now let's go back to the beginning where we talked about our complex number was our real and our imaginary piece. And let's just say that equals z, because we need something there, why not? Okay, so I know that a is equal to r times cosine of theta, and I know that b is equal to r times sine of theta. So I'm just going to replace my a and my b with what my a and my b equal. Okay, so I'm taking this guy and I'm going to plug it into my a, and I'm going to take this guy and I'm going to plug him into my b. Okay, so that gives me r times cosine of theta, and in my b, I have r times sine of theta, and I also have that I on here, and that equals z. Well, between the two of these numbers, I can take out my GCF, and my GCF is r. So I'm left with cosine of theta, and I times sine of theta is equal to z. Now, this is what you need in order to write your polar form. This is the formula. You will also need to know about your tangents. So if I'm thinking about this again, and I'm trying to figure out what my theta is in relationships of my a and my b, the reason that I want to pick a and b is because I know what a is and I know what b is. So if I'm just talking about a and b, then from theta, I'm talking about my opposite and my adjacent. So when I have opposite and adjacent, I'm talking about tan. So in order to figure out theta, we want to do the inverse of tan, and then it's b over a, like that. Okay, now there is a rule. This works really, really well when a is above 0. If a is not above 0, then all you need to know is you are going to add 180 degrees to this answer. So when a is less than 0. There's another rule when a is equal to 0, but I don't want to do that, so not. Okay, so those are your two formulas that you need. All right, so now let's look at a. So on this guy, My A is 3 and my B is also 3. So the first thing I'm going to do is I'm going to figure out my R. So if you remember from a few videos ago, R is your moduli, I don't know, whatever it's called. So but that's basically using the Pythagorean theorem. So we want to square root our real and our imaginary. So we have after they've been squared. So 3 squared and 3 squared. And then you can just plug that stuff into your calculator. I just want the 10th. Okay, sometimes you keep it in radians, but we are not doing that because I don't want to. Okay, so some examples, whatever, they would have you keep it like this, but you know how to do that. So it's just 4.2, so R is equal to 4.2. Now we need to figure out our theta, so we're going to take the inverse of tan, and then we're going to take our B over our A, and since my 3 is above 0, we're going to just leave it like this. Okay, so we're going to plug that in, tan twice, and then it's 3 divided by 3, and that equals 45. So my theta is 45. Okay, so now we're going to plug that into this formula. My R is 4.2 times cosine of theta, which is 45, and I times sine of theta, which is 45. And now I have my answer in my polar form. So this is the complex or rectangular form, and now we've written it in polar form. Okay, and let's try that again. I don't want to do C, but we're going to try that again with E. So we're going to do the same thing. So the first thing we have to do is figure out our R. So our R is -2 squared and -4 squared. So we're just going to type that in. So be careful when you square negatives. You need to make sure you include that negative in a parenthesis or else you'll get a weird answer. And -4 squared, and again it's a radical, but we want decimal to the 10th, so it's 4.5. So R is equal to 4.5. Okay, now we have to figure out our theta. So we have tan of -1, and we're going to do our B over our A. Now, if you remember also, I told you that this is a coordinate. So if we had our cute little grid, we would go -2, -4, which would be here. Okay, so if I wanted to write the complex number from this ordered pair, so then it's left 2, down 4, which is -2 as my real, and -4i as my imaginary. Okay, so this is where I'm getting my A and my B from. Alright, but my A is below 0, so I also have to add 180 degrees to this guy, because these are all in degrees. So we're going to do the inverse of tan, -4 divided by -2, and we're going to add 180 to that, and we get 243.4. So my theta is 243.4, and then I can write my polar form. So my polar form is my R, 4.5, times my cosine of theta, which is 243.4, and I sine of theta, which is 243.4. Now, if you wanted to, we could definitely double check our work, and we're going to do that by doing these problems. So we're going to write this polar form in rectangular or complex form. And the way that we do that is we basically just distribute that cute little -2, or radical 2. So we're going to do this piece, and all you have to do is type it in your computer calculator. So the square root of 2 times cosine of 135 is equal to -1. So this is -1, because remember we're writing the complex form, and the complex form is A plus BI. And then we're going to distribute that root 2 over here to just the sine of 135. Okay, so second square root 2, oops, heavens, got it. Oh no. Okay, like that, times sine of 135. And then we get 1, so then it'll be plus 1, and then you have that I, so the I just attaches at the end. But you really don't need this 1, so it's just -1 plus I, and that is your complex form. And we could do it again. Over here on B, we're going to distribute that cute little radical 3. So I have the square root of 3 times cosine of 210, and that is -1.5, and then we're going to distribute that square root of 3 times sine of 210. And that is negative 0.9i. You don't need this plus minus, so you could just do negative 1.5 minus 0.9i. So now we know how to go backwards and forwards. We're going to check our answers. So let's go back up to A. So this was our polar form, so we're going to check that it makes our complex form if we were to multiply or distribute this 4.2 all the way through. So let's see. So 4.2, heavens, there we go, times cosine of 45, and we get 2.9, almost 3, which is what that is. So that would be 3. And then we're going to do the same thing with sine. So it's 4.2. The reason that it's not exact is because you have decimals, so it's not perfect. And we get 2.9, which is also pretty close to 3. Put the I there. So backwards and forwards, we got the same answer for our complex form, and we wrote it in polar form and in complex form. Okay, if you have any questions, let me know. Have a great day. Bye.